Hello students, today we will be discussing something exciting, and that would be basically the difference between how to understand what is an isotope. So before understanding what is an isotope, we would be understanding how in periodic table how an element is described and how its superscript, which is A, capital A, and the subscript, which is atomic number Z, how it is put, how it is mentioned, and what all things we need to remember in order to understand what is an isotope. Okay, so this is Rennie, and welcome to IGCSE video, and this is basically atomic physics, and we will be understanding what is the how the elements are arranged in the periodic table, but we will be more concentrating on atomic mass and atomic number in order to understand what is an isotope. So let's get into the video. Firstly, what we need to understand is that what is a mass number. Okay, what is atomic mass? Atomic mass is number of protons plus number of neutrons. So we have to add both the numbers. Number of protons is atomic number itself, which is represented by capital Z, the letter alphabet Z. So capital Z is the number of protons, and it is represented by capital letter Z, and atomic mass, which is represented by capital letter A, is atomic number Z plus the number of neutrons. Okay, so A is equal to Z plus N. Okay, that you need to remember. And what is A? A is in the superscript of the alphabet of, here I have taken X, which can be any element in the periodic table, and atomic number comes, Z comes in the subscript. So there is superscript and the subscript. So you need to remember just two things. A is equal to Z plus N, that is A is equal to, it is in the superscript, and atomic number Z is equal to number of protons. That you need to remember. Let's understand what is an isotope. So before understanding what is an isotopes, let us take one or two examples and understand what is, how the superscript is arranged, how the number of protons is mentioned in any element. So let's take an example and understand. We are taking this chart for example. Again, our base would be the X. X can be any element, it can be hydrogen. So instead of X, you can put H also over there, or it can be helium, which is represented by He. So He also can come in the place of X, or it can be Li, which is lithium, or it can be carbon, which is C. And there are many more elements. I've taken just 4 examples for you to understand it better. So X can be any element from the periodic table, and the superscript A is equal to, as we discussed earlier, it is Z plus N. And what is Z? Z is number of, this is the atomic number, which is equal to the number of protons. So let us take the example of hydrogen. Hydrogen element in the periodic table is the first element. Okay, and it is represented by capital letter H, and H atomic number is 1, and atomic mass number, that that is on the superscript A. Okay, it is 1. So H you can see on the symbol H on the left hand side, the superscript atomic mass number comes on the top. That is the reason why 1 is put on the top, and atomic number will come on the left hand side in the subscript. So the 1 is put on the top because A is equal to 1 and Z is equal to 1. That is why instead of Z we are putting 1 in the place of hydrogen. Let's come to helium, so it would be much more clearer to you. In helium, the atomic number atomic number you need to remember it is Z. Okay, and atomic mass number is 4. So a helium atomic number is Z is equal to 2 and atomic mass number A is equal to 4. So He is the element helium. You will put He on the left hand side, A will go on the top, so A is equal to 4. So instead of A you will put 4, so 4, and that is the superscript. So on the bottom on the left hand side, Z is equal to 2. So Z is equal to 2, instead of Z you will put 2. Okay, that is how you have written superscript 4, He, and subscript 2. So now let us come to lithium. Lithium, you can see atomic number, which is Z is equal to 3. Okay, and atomic mass is 7. So instead of A, A is equal to 7. So that will go on the superscript. Li is the lithium element written in short in the periodic table, and 3 is Z is equal to 3. So instead of Z you will put 3. Now let us come to carbon. Carbon atomic number Z is equal to 6. Atomic number is Z, so Z is equal to 6, and atomic mass number is 12. Okay, so in that is A is equal to 12. So A, instead of A you will put 12. C, that is the denotation of the element in the periodic table. Carbon is mentioned C, and instead of Z you will put Z you will be putting 6. So this is how an element is mentioned in the periodic table. If you understand this concept, then you can clearly understand what is an isotope. So let's get into what is an isotope. Isotope, if you see the definition, is the same family members, the element should be same of the similar family members. Okay, and second condition of the isotope is that they have same number of protons but they have different number of neutrons. Different number in a sense, the mass number, as I told earlier, mass number is on the top of any element. So mass number A will differ, and whereas Z will remain the same. So let's take an example of hydrogen to understand it better. So you need to remember A is equal to Z plus neutrons, number of neutrons, and Z is equal to number of neutrons. Okay, so any alphabet, if you element you see, X superscript should be A and subscript should be Z. Okay, so let's take an example of hydrogen. Hydrogen, there are 3 isotopes. As you can see, it's protium. Protium has Z is equal to 1 and atomic mass A1 which is on the superscript. And now we have one more isotope, deuterium. Deuterium mass number is A is equal to 2 and number of protons, that is Z is equal to 1. You can see in both the elements the Z is equal to 1. Now let's take the third example. In hydrogen itself, in the same family, we have one more isotope which has Z is equal to 1 again. That is number of protons you can see in all the 3, protium, deuterium and tritium, it remains the same. Okay, the only difference is the mass number A. Here in tritium the A is equal to 3. So you can see all the 3 cases, A is equal to 1 which is protium, deuterium A is equal to 2 and tritium A is equal to 3. So this follows the condition that these are all 3 from the same family, from the hydrogen family itself, and plus they have number of protons which is similar. You can see Z is equal to 1 in all the three cases, protium, deuterium and tritium, and uh, A number is different. A is equal to 1 in protium, okay, and A is equal to 2 in deuterium, and A is equal to 3 in tritium. So in all the three cases we have the number of neutrons are different. So that is the reason why it is called isotopes of hydrogen. Let's take an example of isotopes of helium. Isotopes of helium, you can see helium, there are three isotopes. You can see Z is equal to 2 is all common in all the three isotopes. That means number of protons in all the three cases on all the three isotopes is similar number of protons. That is why Z is equal to 2. The first case you can see A is equal to 4. That is atomic mass. A is equal to 4. Then second isotope A is equal to 5. And third isotope A is equal to 6. So you have seen there are three isotopes, and all the three isotopes you can see in all the three isotopes there are Z is equal to 2 is common, and the only difference is in the atomic mass. Okay, A is equal to 4. Why? Because the difference is in the number of neutrons. All the three isotopes have different number of neutrons. That is the only difference they have. They belong to the same family of helium, but they have different number of neutrons. So you can see these three are the examples of helium. Now let us consider the example of lithium. Now lithium, if you consider, in lithium also there are three isotopes. You can see there are three isotopes. Okay, here what is there is Z is common. Okay, Z is the as we had seen earlier, Z is the atomic number which represents the number of protons. So here you can see in lithium all the three isotopes are showing the same number of protons, that is 3. That is why in all the three cases it is Z is equal to 3. Okay, now the only difference you can see is in the atomic mass. In the first case you can see it is A is equal to 6. Then in the second case you can see A is equal to 7, and in the third case you can see A is equal to 8. So the only difference is in the number of neutrons present. Okay, because A is equal to Z plus N. So the number of neutrons are different in all the three cases. So there are three isotopes. Okay, there are three isotopes. So in the first isotopes A is equal to 6. In the second isotope A is equal to 7, and in the third isotope A is equal to 8. Okay, now we will see the fourth example, and this is the final example. In this case we have taken the example of carbon. You can see in all the three isotopes the number of protons Z is equal to 6. Okay, that is the number of protons. So Z is equal to 6 is the number of protons in all the three cases. The only difference is in the atomic mass, that is A is equal to Z plus N. So A is equal to, in the first case A is equal to 12, in the second case it is A is equal to 13, and in the third case it is A is equal to 14. So only difference is in the number of neutrons in all the three cases. So this fulfills the condition that these are isotopes from the same family. First we had seen the example of lithium. In lithium there are three members from the same family itself, and in carbon also there are three members from the same family. their protons all are the same. That is why they are from the same family. Z number, Z is equal to the same. All the three cases you can see the isotopes, they are from the same family. The only difference is in the number of neutrons. So this is what makes it different for the isotopes. If you understand this concept, you can solve any aspect. Okay, so this is what I need to mention. Thank you and thanks for watching. You too have a great day. Thank you very much.